Here once again we are working with applications of derivatives. Specifically with the first derivative, we're looking for critical numbers, we're looking for relative extrema, and we're looking for open intervals of increasing and decreasing. So we'll start with number 17. We have f of x is equal to x squared times 3 minus x. In this particular case, I would probably just multiply this out. I think it'll be much simpler. So we're going to get 3x squared minus x cubed. That's not the derivative. That's still a simplification of the original function. So now we're going to take the first derivative, and that would be 6x minus 3x squared. We want to set that equal to 0, and that'll happen. We'll factor out a 3x times 2 minus x equals 0. So we get x is equal to 0 and x is equal to 2. So we're going to make our number line, put our critical numbers of 0 and 2. We're going to find some test values, negative 1, 1, and 3. And we're working with the first derivative here. We're going to plug those into the factored form. So that will make our life much easier. So 3x when x is negative 1 will be negative. 2 minus x when x is negative 1 will be positive. And so we'll have negative times positive is negative. When x is equal to 1, we're going to get positive, positive, which is positive. When x is equal to 3, we're going to get positive times negative, which is negative. So once again, we have decreasing, increasing, decreasing. We have our min at x equals 0, our relative min, and our relative max at x equals 2. So we're going to summarize this briefly. F of x is decreasing on the open interval from negative infinity to 0, or from 2 to infinity. F of x is increasing on the interval from 0 to 2. We have a relative minimum at x equals 0, a relative maximum at x equals 2. And so that'll do it for problem number 17. We'll go on to problem number 19. Now before we start problem number 19, if you look at problem 18, we could also multiply that all out. That may be some more trouble. We might want to use the product rule first with that as well, and a chain rule with that too. I think that number 19 is probably a little bit easier here because we just bring out the 1/5 and it would be fairly straightforward. So I'm going to try to do number 18 here instead of 19. And I have f of x is equal to x plus 2 quantity squared times x minus 1. And instead of taking the way of multiplying out, which could be done here, and some might find that easier, I'm going to go ahead and use the product rule with the chain rule here. So I have the first function, which is x plus 2 quantity squared, times the derivative of the second, which is just 1, plus the second function, x minus 1, times the derivative of the first function. We'll have to use the chain rule here. It's bring down the 2, reduce the exponent to 1, leave the inside alone, times the derivative of the inside function. And we will end up with x plus 2 squared plus 2 times x minus 1 times x plus 2. At this point, I will factor out a common factor of x plus 2, and that will leave me x plus 2 plus 2 times x minus 1, or 2x minus 2. And when I simplify that up, I'm going to get x plus 2. The 2's will cancel out here. And x plus 2x, which is simply 3x. So I could also write it as 3x times x plus 2. Alright, so there I have my zeros at x equals 0 and x equals negative 2. I'm going to do the same thing I've always done. I'm going to draw a number line and plot my critical numbers at 0. We'll make that one negative 2 instead. put 0 to the right. I'm going to find some test values, -3, -1, and 1. And recall that I'm using the first derivative there. All right, so I'm going to work with the factored form. When I plug in -3, I'm going to get negative times negative, which is positive. Plugging in a -1, I get negative times positive, which is negative, and plugging in 1, I get positive, positive, which is positive. And so I have increasing, decreasing, increasing. And I have a relative max, a relative min. And I'm going to summarize. F of x increases on the open interval from -infinity to -2, or also on the open interval from 0 to +infinity. F of x is decreasing on the open interval from -2 to 0. We have a relative maximum at x equals 2 and a relative minimum at x equals 0. So that'll do it for this video. We'll go on to some more examples in the next.